Hello, and welcome to my talk on giving Spring a voice, integrating Spring with Amazon Alexa. I'm Craig Walls. I am a software engineer with VMware, and here's all the information you can see about me and where you can follow me and reach me after this is done. But with that said, let's go ahead and get started. And I'd like to talk a little bit about myself. I don't normally like to have an intro, who's the speaker, set of slides, or anything like that in a talk. But on this particular talk, I would rather give you a little bit of information about myself and why I'm even talking about this subject. First off, I'm a Java developer, and I've been a Java developer forever. I started working with Java back when it was Java 1.0.2, and I have been a Java champion since 2021. So you can say I've been around and I've been doing Java for a very long time. I'm also a member of the Spring engineering team, and I've been working with Spring for a very long time, since it was, as I recall, Spring 0.9, and we're up to Spring 6 now. And so we've come a long way, and I've been with Spring for that entire ride. I've also written a few books on Spring, most notably Spring in Action, which is now in its 6th edition. And more recently, and by more recently, still in the last 5 or 6 years, I have taken an interest in voice application development, specifically for Amazon Alexa. And so I tried to find a way to bring all of these interesting things together. And while this is who I am today, let's take a step back a little bit. I've always been a big fan of science fiction. Even as a young child, I watched all of the Star Trek, Lost in Space, Star Wars, whatever that my parents could endure. And as I got older, I was also into things like Knight Rider, the written works of Isaac Asimov, and the newer Star Trek series, and even more recently, things like the Marvel Cinematic Universe. A common theme in all of these is that computers talked. The Enterprise computer, the robot on Lost in Space, droids in Star Wars, Kit, the Knight Industries 2000 car, our Daniel Oliva and Jarvis, Friday. These are computers that people talk to in order to get information and to get things done, and that talked back to you. Well, that was great, except the promises of science fiction sort of fell flat when I got my first computer. Now, what you see here is a Commodore VIC-20. I was excited about the possibilities computers would bring, but when I got this VIC-20, it was sort of fell flat. I mean, I couldn't talk to it. I had to type at it, and if you've ever worked with a Commodore computer like this, you know the keyboard was very special. I quickly got a Commodore 64 shortly after that, same keyboard. I still couldn't talk to it. I was disappointed. I couldn't talk to these machines. I could only type to them, and they wouldn't talk back. They could only display results on a screen. Well, at the time there was a game called Echelon, and Echelon came with this thing called a lipstick. And effectively, the lipstick promised in the advertisements for Echelon, it promised that you would be able to talk to your game as you're playing it. And the thing is, I never got the game. I never owned it. And in hindsight, I'm pretty glad I never owned it, because it would have been a waste of money. Because it turns out the lipstick was literally nothing more than a fire button. The idea is that when you're ready to fire on another ship, you would say fire. But from what I'm told, it would actually fire when it heard any noise. You could just say to it, and it would fire something. So it was just a fire button you wore on your face. It wasn't a voice experience. And it wasn't until the early 2000s that I finally got an opportunity to see this thing called Siri. And everybody knows what Siri is. It lives on everybody's iPhone or iOS device or their watch, even on Macs now. And Siri was exciting, and it was interesting, and I was so excited on what I could possibly do with it. But as it turned out, as a developer, Siri left me wanting. Developing for Siri is not a terribly exciting experience, and I won't go into the details of why, but it just didn't set well with me as a developer. As a user, it's pretty nice. I use it for timers and whatnot, but as a developer, not very exciting. And so when Alexa came along, after so many disappointing false starts with voice user experiences in the past, I was skeptical, and I didn't jump on the Alexa bandwagon right away. But then in early 2018, I decided to give it a shot. I got my first Echo Dot, and I developed my very first simple Alexa skill or Alexa application. The word skill is a term that within Alexa means voice application. So I developed my very first simple Alexa skill. And although it was simple and kind of dumb, I was hooked. For the first time, I could see the promises of a real voice user experience, and I could see how I could build voice experiences on top of other applications. And it wasn't long before I had several Alexa enabled devices all over my house, and voice tech had finally arrived in my house. What can I do with it? Well, it turns out a lot of Alexa skills are simple. There are tons, and I don't know the exact number, but I want to say it's in the hundreds of thousands of Alexa skills that are published out there. And they mostly, unfortunately, mostly are fairly simple. Sort of like the skill that I created when I first started out with this. And can it do anything else is what I kind of wonder. Can I do more than just simple things? Most people know you can use it to turn on lights, you can play music, you can set timers, but you can also create your own voice experiences. Again, you can create these skills. So what kind of skills can you create? I looked around and I found there's a lot of fart sound skills that you can use to make sound effects, or in many cases, the fart sound. That seems disappointing. But no, there's tons more. There's a lot more that you can do with Alexa. And if you look around, there's several different great applications out there for many different industries, including travel, banking, and others as well, that different organizations have built voice experiences on top of their existing applications using Alexa. Well, as it turns out, Alexa fits in pretty much the same place as any other UI. So imagine you have here your app's backend stack. Imagine that you have some server API or maybe multiple APIs in the backend, and you have some UI. Maybe it's with React or Angular or Vue, or maybe it's an iOS app or even a desktop app, and these are interacting with that backend API. Well, what if that backend stack was Spring? And what if that, instead of React, Angular, or Vue, or in addition to those things, what if it was Alexa? As it turns out, it fits in the same way, and the interactions are pretty much the same opportunities you have for communication. You have those same opportunities. You still have HTTP, RSocket, messaging, and as well as many other options for Alexa, for your voice application to interact with the back end. Now, when you're developing for an Alexa, do you develop this in Java? I mean, as a Spring developer, you're probably familiar with and love working with Java, or at least some JVM language, maybe Kotlin or something like that. Are you going to be able to do that and carry those skills over to Alexa? And the truth is, you can, but with some caveats. You have several choices when you're developing for Alexa. The most common choices, and the ones that are kind of supported out of the box, are Node, Python, and Java. And that said, this stack kind of gets a little bit fuzzier as you go from top to bottom. By far, Node is the most supported, most well-known, most tooling-wise, resource-wise. It's one of the most practical options. Python is shortly right behind it. And I do know several voice developers who are using Python to develop their applications for Alexa. Java is also an option, but you're limited. There's simply, unfortunately, not as many tools available for developing voice apps in Java, nor are there nearly as many resources. But it is an option, and it is an option that's officially supported with the Alexa SDK. But you can also develop in pretty much any language. Any language that you can develop an app in that can handle a post request could be the language you choose for developing for Alexa. That said, for me, I prefer Node, mostly because, again, the resource-wise, tooling-wise, it's much more available. I'm just nothing wrong with Python. I haven't really fully grasped and got excited about Python. And Java, again, Java, as much as I love Java and as much as I work with it, and I'm happy to work with it when I'm developing in Spring, I just find it difficult and not as much fun to work with when I'm developing for Alexa. So here's what we're going to do in the rest of this talk. I'm going to show you a pre-baked skill, an Alexa skill that I've already created that it integrates with a backend Spring API. I'm going to show you a little bit about how to test it locally, and I'm going to talk about this thing called account linking and when it comes to security around your API. So with that said, let's see some code. All right, for our demo, we're going to have three basic components in our application. The authorization server, which is going to offer an OAuth 2 authorization server that's going to grant permission to our client, ultimately, which is going to be an Alexa client. Initially, I'm going to pretend to be the client, but it's going to grant permission to the client to access our API, our resource server. Then we have our Books API, which is our resource server, and the Books API is going to allow some operations for free without having any sort of authorization, but it's also going to require a proper authorized access token to do things like maybe adding a book to a list. All right, and then our third component is the Alexa skill itself. I got that in a separate editor. We'll bring that up in a moment. First, let's walk through the Spring code that makes all this happen. And we're going to go through it very quickly. I'm going to go ahead and start it up and get it running just so we have it ready to go when we're ready to try it out. But let's look at the authorization server. Now the authorization server is, as you can notice, the most important thing you can see here is that it's built against Spring Boot 3.10 RC1. That's great, because starting with 3.1 milestone 2, we got some awesome, amazing auto configuration support for Spring authorization server. Prior to that, there's a lot of code you had to write yourself to do even the most basic authorization server. But now you start off with a very basic, very auto-configured authorization server, and then you can configure what you want on top of that. But to start off, you don't have to do much of anything. And in fact, in my demo, I'm not going to do much of anything. I'm going to stick mostly to the basics, to the defaults that the auto configuration gives us. All right, then down here I have a few other dependencies. Of course, we have Spring Security, we have Spring Web, we have an authorization server. This is the most important piece of this. We have the Spring Security OAuth 2 authorization server dependency in here, and a few other things that we won't worry about right now. Now my authorization, my application, this is just a typical Spring Bootstrap application. Nothing to see here. Our security config is where the bulk of it happens, and all we're even doing in here, thanks to that auto configuration support that Spring Boot milestone 2 gave us and carried over into RC1, we are able to not really to configure much security stuff here other than a simple user detail service. The user detail service in this case is just an in-memory one. It has a single user whose username is Habuma, whose password is password, and it's in memory. Now in a real world application, in a production application, we wouldn't do this. We would probably have some more sophisticated user detail service, perhaps keeping track of user details in a database or LDAP or something else, something more sophisticated than just an in-memory user details manager. But for our purposes, this is going to be fine. Okay, great. Well, where's all the configuration for the authorization server? Well, again, Spring Boot milestone 1 took care of a lot of that for us, but we do have to define our client. We have to tell it about our client, and that is over here under source main resources application.yaml. Now, first off, notice I am running on port 9000. This is because I'm going to run everything I show you today is going to run locally on my machine, and that's going to just make things a lot easier for me, but I need to make sure the ports don't collide. So authorization server is going to run on 9000. Then down here I define a single client. Now in a real world application, what we would probably do is we would have our clients defined also in a database or some other more sophisticated storage than defined here in an application YAML, but for our purposes this is going to be fine. I'm saying that my client's name is my client. It has a single client secret of secret. I'm not really encrypting that. That's what the no-op's about. It's going to use HTTP basic to authenticate itself. The client's going to authenticate with the authorization server using HTTP basic. It's going to support the grant types of authorization code and refresh token. And then you see down here 4 redirect URLs. The first 3 are those that are required by Amazon Alexa for their redirects. Now, we haven't got around to that yet, but just know that these are the 3 basic URLs you're going to need. The only thing that'll be different for you when you try this out is every developer gets their own vendor ID, and this is my vendor ID. You're going to want to use your vendor ID when you do this. But other than that, these URLs are exactly the same. Then right here, we have our localhost one. This is going to help me develop and test some of this stuff locally during our demo. And then we have one scope, just simply books write. We're going to be able to read books from our API for free all day long, but in order to add a book, you have to have books write permission. Okay? All right, great. Let's fire that. Oh, it's already fired up. Let's go take a look over at the API itself and see what it has to offer. And taking another look at the POM file, you can see we're building against Spring Boot 3.1 RC1 again. We have Spring Data R2DBC. We're going to persist to an H2 relational database, an in-memory database. We're going to persist to that using a reactive relational database connectivity, or R2DBC. We're using WebFlux as our API front end. Instead of Spring MVC, we're using the reactive flavor of Spring's web framework called WebFlux. We have Spring Security, and we have the Spring Security OAuth 2 resource server dependency in there. Now, when you come over here, I'm not going to walk you through everything, but just take a quick glance at book. Book is an ID, book is a record that has an ID. This is annotated with Spring Data's ID annotation. But other than that, just a simple Java record, nothing terribly exciting to see here. Our repository is just a reactive CRUD repository. The only thing that may be special if you've never worked with Spring Data's reactive support before is that instead of extending CRUD repository, we're extending reactive CRUD repository. Our controller is going to make use of that repository to offer 3 endpoints, or actually 1 endpoint, but 3 types of handlers. A get mapping to get all books, so a get mapping for a get request for /books is going to get all books. A get mapping for /books/ID is going to get a book by its ID, and a post mapping the book is going to save a book. Now we're only going to really focus on the first one and the third one. We're going to get a list of books, and we're going to be able to save a book, but nothing else matters here. We're not going to really worry about this one. This was just here for debugging and testing purposes. We're not going to use it during the demo. And then finally, Java-wise, we have our application runner, which basically, because we're using an in-memory database and every time we restart the app, it's going to start over with a fresh, clean database, the first thing my application runner is going to do is load up 2 test books, Harry Potter and The Shining. It's going to load those up into the database so we don't have to keep adding them every time. They're just always going to be there for us. Great. Well, where's our resource server configuration? Well, the only resource server configuration we needed, because again, thanks to Spring Boot auto configuration, the only resource server configuration we needed is to tell it where the JWKS, or the Java Web Key Set. Honestly, I don't know. I probably don't know the real full acronym expansion, but the JWKS, the JWK set ID. This is how we're going to how the client would verify that the token that it's using or that it received is actually a valid token and wasn't just made up by somebody else and handed to them. Instead, it's going to verify that the token is actually a token that was issued by the authorization server. So this is pointing back to the authorization server at port 9000. Oh, the other thing is this is running on port 8081, just to stay out of the way, because port 8080 is going to be kind of set aside as our quote-unquote client, which again, we don't really have a client yet, but we're going to pretend that we do. And that way the redirect will go back to port 8080. And it'll fail when we do, but at least we'll have enough information from what we get to be able to try this out. Okay, great. Now I'm going to pull a window over. We're going to kick the tires on our resource server and our authorization server. First off, I'm going to use HTTP IE. If you're not familiar with HTTP IE, it's just a HTTP client, command line client, very similar to curl, but a little easier to use in most cases. I am going to use curl for one example here in a moment, but for most of the stuff, I'm going to use HTTP IE. I'm going to say 8081/books, and this should list all of my books for me. And it did. We got Harry Potter and the Sorcerer's Stone, and we got Stephen King, The Shining. Great. Let's try to add a book now. So HTTP 8081/books, and this is what's wonderful about HTTP IE is I can just start giving it titles, like maybe Spring in Action, and an author, Craig Walls. I hear this is a good book. And I'm going to hit enter, and oh no, it didn't work. And the reason it didn't work is I got a 401. And the reason I got a 401 is because I tried to add a book. I tried to write a book without giving it proper permission. And let's take another look back at that security configuration. And the reason that happens is I have set up an authorization server, an OAuth 2 resource server here. I said authorization, I take that back. I set up an OAuth 2 resource server here. And as a consequence of that, any post request to /books has to have books write scope. And I made a request without a token, without any sort of authorization. It does not have books.write scope, so it gave a 401. Well, how can we fix that? Well, to fix it, we need to get a token. And to get the token, I'm going to copy from my little cheat sheet over here, and I'm going to open up a window. I'm going to open up Safari. And I'm going to paste into my Safari window, I'm going to paste this URL. Now, the URL I pasted before it redirected is basically specifying that we're going to the OAuth 2 authorize. Let me see if I can get this where we can see it better. Go to the OAuth 2 authorize endpoint on our authorization server. The response type we're asking for is code, or known as authorization code response. We're asking for a code to come back. Our client ID is my client, which is what we configured it in our authorization server. Our redirect URL is 127.0.0.1.80.80. Again, there is no application running there. I'm going to pretend to be that application for this part of the demo, but it's going to go to basically 127.0.0.1.80.80/authorized, and we're going to ask for books write scope. And we got a little state variable here. If you're not familiar what state variables are for with OAuth, I encourage you to look that up elsewhere. I'm not going to talk about it. But now that I've done that, it's going to redirect me here. Ignore all the things that 1Password is trying to do to me right now. And I'm just going to log in as Habuma and password. I'm going to sign in, and I do not want to save that in 1Password. And I'm going to say, yes, I want books write consent. I want to give consent to do books write. Now, what the page you're seeing here, the previous page you saw was the standard default Spring Security login page. This is the standard default authorization server consent page. Now, you can replace those and dress them up and make them look as nice as you want, but I'm just sticking with the defaults for today, and I'm just going to say submit consent. Now, I got an error because I don't have anything running on port 8080. When it redirected to my client, which should have been listening on port 8080, there's nothing there. That's okay. I'm pretending to be the client. So what I'm going to do is I'm going to pretend to be the client and take this code that it gave me in the redirect, and I'm going to use that to get a token. And to do that, I'm going to first off put it in a very convenient place. I'm going to put it in an environment variable. And then rather than have you watch me type a bunch of stuff, I'm going to copy something out of my cheat sheet, this curl command that is going to go to localhost 9000 OAuth 2 token. It's going to go to the authorization server's token URL. It's going to exchange, among other things, it's going to exchange our code, which is here, for a token, and it's going to do that using the client and the client secret. And look, we got an access token back. You can see the JSON response here is an access token. Now, if we wanted to, we could take this and go over to jwt.io, or there's a really nifty command line tool called JWT that essentially does the same thing, and it cracks open that token and shows me all the good stuff about it. Among those things, it shows me how it's broken out into the different pieces of a JOT token. It shows me the header, it shows me the payload, and most importantly, it shows me that Habuma, my client, for the Habuma user on my client has books write permission. That's the most important thing we got. Also, the issuer was my authorization server and things like that. And then here's the signature. I'm going to leave that up to you to worry about, exactly what the components of a JWT token are. But we're going to use that now. We're going to use that to add a book to our API. So I'm going to say 8081/books, just like we did before. I'm going to add a different book this time. Maybe Build Talking Apps, also by Craig Walls. I hear that's another great book you might want to check out. I'm going to say -a bearer. This is going to say we're going to use the bearer token, and -a, well, I should have assigned that token to a environment variable, but since I didn't, I'll just paste it here. Oops, I failed to do that, so I'm going to have to go up here and copy my token again, paste it here, and look, it just added a book to our API. So now if I go ask for books, again, the listing of books doesn't require a token, and you can see that it added the book. Fantastic. We have 3 books in our API now. Now let's see how we tie this all together with the Alexa skill. All right, so now let's look at the Alexa side of things. I've created an Alexa skill called reading list, And it has already been deployed and built and all that because I didn't want to have you see me do all that. But I'm going to give you a quick walkthrough. I'm not going to go into the details of how to develop an Alexa app. I will tell you the basics are I use a tool called the ASK CLI, or the Alexa Skills Kit command line interface. That's how I usually work. And I say ASK new at the command line, and it walks me through a series of questions, after which it spits out an application for me to work with, a basic Hello World template application for me to work with. And then because I'm using what's called Alexa hosted skills, in order for me to deploy it, I just say git add, git commit, git push, and after a little while it picks those things up and deploys them for me. All right, that said though, let's walk through this app really quickly and show you some of the highlights. Again, I'm not going to walk through it in detail. If you want to know more about how to develop Alexa skills from the ground up, by all means, check out some of my other videos. There's going to be a link to that, or a QR code to that at the end of the talk in my slides, where you can see some more videos on how to do that. Check out my book, or just email me. I'll be happy to help you out. So I'm going to give you some highlights though. First off, there are two parts to an Alexa skill. There's what's called the interaction model, and this defines how the user and Alexa will interact with each other. And then there's the fulfillment code, which is the typically JavaScript or Python code, or potentially Java code, that your application is going to implement the behavior and the function of your Alexa skill. So the interaction model you get when you first build a brand new skill. When you initiate it using Ask New, it has a simple English US interaction model, and it's in this JSON file. Now I've added some stuff to it since I first started this, but a couple of the highlights just for you to take a look at. We have the invocation name. This is essentially a vocal icon. This is how you invoke the skill. You would say something like Alexa open reading list, or you might say Alexa ask reading list to do something, and it will open up that skill and it'll do what you ask it to do. And my other device in the other room just heard me say her name, and so she's talking right now. Hope you didn't hear that. But regardless, in this case, my invocation name is reading list. When you first start, I think it's set to change me, and you obviously should change it and pick whatever you want. Okay, but then you have these things called intents. These are the things you expect, the user expects the skill to do for them, to either answer questions or to take some action. And there's some built-in ones here. We have, you see them, they start with Amazon, all capitals. We're not going to worry about those. I want to focus on two intents that I've added: the list books intent and the add book intent. Now the list books intent is the simpler of the two. It is going to simply list books, and it doesn't have any things called slots. Slots are essentially parameters. We'll talk more about that when we get down here to add book. But for list books intent simply has no slots, but it does have several what we call utterances. So an intent is a very precise, here's what we want to do. Utterances are the things a user may say to cause that. So a user may say things differently. In fact, even the same user may choose to trigger an intent by saying something different each time they use the skill. And so you have to sort of, to some degree, anticipate what a user might say. And so that's why I've created several sample utterances here, such as what books are on my list, what books are on my reading list, list books, list my reading list, list all books. And you don't have to be comprehensive here. Under the covers, there's some machine learning magic that happens after you deploy this that builds this model and creates additional things that sort of mean the same thing as what you've provided here. Of course, you don't have to be as comprehensive as possible, but the more comprehensive you are, the more sample utterances you provide, the more accurate that machine learning magic's going to be when it produces additional things. So that's my list book intents. If I say list books or list my books or what books are on my list, Alexa's going to take us to the list books intent. I'll show you how that's implemented here in a moment. Now, there's also add book intent. Add book intent is going to react to when I say add, and there's a placeholder here called book, add The Old Man and the Sea, or add Little Women to my list, or add whatever, To Kill a Mockingbird to my reading list. If I say these things, then the add book intent is going to be triggered. Now, for every slot you have, you can have as many slots as you want in your intent, and not every utterance necessarily has to accept a slot. You could have some slots that are optional, and so if they leave it out, then it just wasn't specified. But here you have to give it a type. And so I've given it a type called Amazon Book. This is one of Amazon's many built-in types. Amazon has a very rich set of built-in types, and they're usually used for not so much for validation, although you can do it to validate the input. They're used more just to help the voice recognition understand and sort of disambiguate what you meant. So if it thinks it heard one thing but it's not sure, it can kind of bounce it against a list of known values and say, okay, well, I wasn't sure what I heard, but it matches this, and so it matches up against that. And so in this case, I've asked it to match up whatever is said in these slots to the Amazon book type. And what's wonderful is Amazon has a long list of books. It knows pretty much every book on the planet, at least most of the major ones anyway. And so you don't have to worry about it. Amazon, they know books, okay? If nobody knows books, then it's Amazon, okay? So you can say Amazon, or you could ask the skill, add The Old Man and the Sea, or add Little Women, or add To Kill a Mockingbird, or add Moby Dick, or whatever, and it's going to recognize that as a book, and it's going to give it to my intent, to my intent handler, which is part of the fulfillment. Now, index.js is where most of the stuff takes place. However, I tend to prefer to break things out. So I've done that for my list books and add books intent handler. So I've broken those out into separate JavaScript modules, and those are here. So let's take a look at list books intent handler. And it's the easiest of the two by far. It doesn't have any inputs. It just simply says, okay, let's use this library called Axios to make a request to localhost 8081. Now, you'll recall that is where my books API is listening. It's going to make a request to localhost 8081 for books. It's going to get the response back. It's going to form that into some text, some speech that is going to be spoken, and then it's going to return that. It's going to create a response with that spoken output. And Alexa's going to say, here are the books in your library, and it's going to list all those out. Easy peasy, no problem at all. And as you'll recall, getting a list of books does not require an access token. So this is just going to work. It's just going to work. As long as the API is there, it's just going to work. Add book's a little bit more interesting. I'm going to focus on certain details of it and just sort of gloss over others. But the main thing we're doing here is we're pulling the value of the book slot out. That's what we're doing here on line 10. Then we're taking that resolution. We're going and checking its status code of the resolution to make sure it matched. Did Alexa understand it? So because even if Alexa didn't understand it, it'll still give you the value back. It's just going to say, okay, but Alexa may say, I didn't understand that. So we're going to check to see if the ER, or the entity resolution, has a successful match. And if we do, great. If we don't, you could choose to go ahead and add the book anyway, regardless, and use whatever values there anyway. But for my demo, for my example here, we're not going to add the book if we don't understand it. If Alexa had no idea what the book was, it's just simply not going to add it. So it's going to say, I'm sorry, I didn't know what that book was. Please try again. And it's going to send that back as its response. But assuming it did understand the book, the next thing it's going to do is it's going to do something called get book data. I'll talk about that in just a second. Bear with me. But the main thing it's going to do is it's going to take that book data it learned, it's going to add it to the reading list. And adding to the reading list is either going to work, or it's going to, with a 200 or 201 error, status code, and it's going to say that it added it. Or it's not going to work, and it's going to say, I'm sorry, I had trouble adding it for some reason. Maybe the API was down or something. Or it's going to catch an error, in which case it's going to say, I need permission to add books to your reading list. Now, how does it know? What are these possible status codes and errors that we're catching? Well, that's down here in add book to reading list. Add book to reading list is going to go first off and try to get an access token. It's going to get the account linking access token, the token that our Spring authorization server is going to give it. It's going to take and get that and put it, and it's going to use it. Now, where does it come from? How does Alexa even get this thing? It's because via account linking, which we haven't even walked through exactly yet, but via account linking, once a user has authorized a skill to access a resource through an authorization server, it's going to put an access token in every single request going to your skill. Now, whether you use it or not is up to you. But once it's authorized, even though it doesn't need it, our list books intent handler is going to get that access token. It just will ignore it. It won't use it. But here in add book intent handler, it's going to get that token out of the request. It's going to check to see if it's there. If it's not there, it's going to throw an error and say no access token, which is what gets handled in this catch up here. We'll come back to that in a moment. And then, but if it does have it, it's going to create the headers with the authorization, bearer token, whatever the token value is, and it's going to post to books with whatever that book date is, therefore hitting our API, our Spring Webflux API. Now back up here in this catch block, the reason that catch block would happen is if we don't have an access token. We don't have the ability to add a book to the reading list. And so in that case, it's going to say, I need permission to add books to your reading list. Please link your account to the Alexa app. And it's going to add this thing called a link account card to the response. And then of course, it's going to build up the response and return it back. And what a link account card does is it shows up in the user's Alexa application on their phone or their tablet. And then they can go in there, and from that card, they can tap on things and grant access. All right, that's essentially how it works. Now, I did promise I was going to talk about the get book data. I'll talk about it as briefly as I can. Essentially, there's a lot of code there that what it does is under the covers for certain types, certain slot types, certain entity types, Alexa has knowledge of those types more than just simply what their name is. In the case of books, it knows what the book title is. It knows who the authors are. It may know who the publisher is. It knows a lot of different things about a book. Cities are another example. In the case of cities, it knows the city name, it knows what state it's in or what country it's in or what province it's in, it knows who the mayor is, it knows a lot of different things about those entities in case of a city. And there's other types as well that Amazon knows about. So what this is doing here is it's taking that book slot that we got from the user. The user said to add To Kill a Mockingbird, and it's going to take and look that up and determine some additional information about it, such as the author name, so that when we do add it, we don't have to tell it who the author is. The user doesn't have to say who the author is. Alexa's just going to know, and it's just going to add that for us. Okay, great. Now, one other thing, and before we can kick this off, is we have to deal with account linking. And there's this file down here called linking.json. Now, this linking.json file is sort of a transient file. You don't typically keep it around. I do for demo purposes, but typically it's one of those things you create, you use it, and then you throw it away. Because what's happening is this linking.json file has in it all the information from a client's perspective about how to access the authorization server and to get a token. It knows things like the client's client ID. It knows about the client's secret. It knows about what scopes we're asking for. It knows about the authorization URL, and it knows about the access token URL, among other things. Now, you may notice that my authorization and access token URLs here are based on ngrok. And the reason for that is I'm running everything locally. I'm going to run everything on my local machine, but unfortunately, the actual understanding of what I say to Alexa still happens in the cloud. And so when it tries to go, even though my skill is going to be running local, my JavaScript code behind my skill is running local, the cloud, the natural language understanding, all this account linking card, everything like that still happens in the cloud. So I need to tell it where the authorization server is, otherwise it's not going to be able to hit localhost 9000. So to do that, I'm going to pull over a window, just so I'm not hiding anything. Let's say ngrok http 9000. And that's going to start everything up on ngrok 9000. I'm going to copy this URL as my base URL here because I'm going to need it. I'm going to drop that out of the way, and I'm going to come in here and just paste it on top of all this, which it looks like it didn't change since the last time I did it, but if I don't do that, yeah, it did change. There was a little bit that changed right there. And so I saved it, and now we need to apply that account linking. And the way we apply the account linking is, well, I'm going to consult with my cheat sheet, because if I don't, I'm going to get this wrong. But I'm going to pull another window over here, and I'm going to get my skill ID. The first thing I need to do is get my skill ID. And the easiest way to do that is to go take and look in a file called ask states, and it's going to be right there. Now, if you're clever like I am, you've created an alias that helps you do that. So you can say get skill ID, and it's going to go look in there and essentially pull that out for you. So there's my skill ID, and I'm going to say ask SMAPI. There's the Alexa API for working with your skill. Is called SMAPI. I can't remember exactly what the SM stands for. API is API, but skill management API, I think is what the M stands for. So skill management API, I want you to update account linking info. Specifically, I want to do that for the skill whose ID is what I just got up there. And I want to tell it where the account linking request is this file called linking.json. And if it all works, it's going to come back and tell me that it executed successfully. Great. We're kind of done with that. So I'm going to move that out of the way. And then we're ready, almost ready to start this. In fact, I think we are ready to start it. I could just go ahead and reuse this window. I'm going to run it locally. Now, everything's deployed. It's already out in the cloud. It's running in AWS Lambda. I could test this right now. The problem is when it tries to go to my book API, it's going to try to hit localhost 8081, which it's not going to be able to access from AWS Lambda. In order to make that work, I would have to change the URL. I'd have to set up another ngrok. It's just a beating. And as I'm developing skills, I like to do this instead. I like to say ask, run, and then watch is optional, but watch it allows me to make changes and it'll restart it. What this is going to do is it's going to run all my Lambda stuff locally, and then it's going to also set up in the cloud. It's going to tell the Alexa portion of the app in the cloud that, hey, when you send requests to that skill, the actual skill is running at this URL, and it's going to basically redirect everything to my local machine for development purposes. This is not going to affect your end users. This skill is not going to be published. Nothing that even if it's published, you have a development mode that you're working in, it's only going to impact you. It's not going to impact your users. So in development mode, you can do this. So now that it's running, I can do this. I can use my actual Alexa device, and I have an Echo Dot sitting here on my desk, and I'm going to talk to my Echo Dot, and I'm going to say this. Alexa, ask reading list to list books.
Here are the books in your library. Harry Potter and the Sorcerer's Stone by J.K. Rowling. The Shining by Stephen King.
And those are our two initial books that are app runner or application runner in the Spring Boot API set up. I've restarted the app since we added Build Talking Apps by Craig Walls, so it's no longer in there. But these are the two initial books that get loaded by the application runner. Now let's try to add a book. Alexa, ask reading list to add The Old Man and the Sea.
Welcome. You can say hello or help. Which would you like to try?
Add The Old Man and the Sea to my reading list.
I need permission to add books to your reading list. Please link your account in the Alexa app.
So clearly it wasn't able to get the token. And so what I need to do is I need to go to my Alexa app on my phone and give permission. Now, I'm not going to hold my phone up to the screen so you can see what's going on. That would be ridiculous. But as I go along, I'm going to go ahead and add these things, and I'm going to take screenshots, and then I'll kind of edit them into the video so you can see what's going on. So you can see the same things I'm seeing. So I'm going to go to this thing in the Alexa app called Activity. I'm going to make sure it's refreshed so I see the latest stuff. I'll take a screenshot of that. And you'll see that I've already done this a couple of times before. And then I'm going to click on Link Account. I'm going to click on Link Account. There it goes. And the first thing I'm going to see is I'm going to see the sign-in page from my authorization server, which is just essentially your Spring security sign-in page. So I'm going to sign in. I'm going to sign in as Habuma. Oops, let's make sure I get that right. Habuma and password. And before I click sign in, I'm going to take a screenshot. All right. And then I'm going to say sign in. And now I'm getting my consent required request. I'm going to check on books right. I'm going to take a screenshot real quick. And I'm going to click on submit consent. And now it's going to spin for a minute, and now it's come back and it says your reading list account has been successfully linked. And then I can close that and we can move on. But now let's try it again. Alexa, ask reading list to add The Old Man and the Sea.
Adding The Old Man and the Sea by Ernest Hemingway.
So it knew that Ernest Hemingway was the author of Old Man and the Sea because it looked that stuff up from what Amazon already knows about the book. Let's add another book just for grins. Alexa, ask reading list to add To Kill a Mockingbird.
Adding To Kill a Mockingbird by Harper Lee.
Great. Now let's make sure that those were added. Alexa, ask reading list to list my books.
Here are the books in your library. Harry Potter and the Sorcerer's Stone by J.K. Rowling. The Shining by Stephen King. The Old Man and the Sea by Ernest Hemingway. To Kill a Mockingbird by Harper Lee.
And there you go. We have just linked an Alexa skill with a backend Spring Webflux API that is secured by OAuth as a resource server and whose tokens are obtained through an authorization server. And the entire OAuth flow took place in my Alexa app on my phone. And it was all handled entirely by Alexa. The only thing I had to do was tell Alexa where all that stuff was at by configuring my skill with an account linking request. Well, now that you've seen how account linking works with Alexa and how it provides an access token so that the user can interact with their voice application and talk to a secured backend resource server, let's talk a little bit about this thing called voice forward account linking. Once you start getting into developing with Alexa, you may find a little bit of documentation about this and wonder, well, what is voice forward account linking? Or maybe you haven't seen this yet and you're wondering, well, why do I have to go to my phone? Why do I have to go through all those steps on my phone? Why can't I just grant voice permission directly? Why can't I just tell Alexa, yes, I grant permission? And that's what voice forward account linking does for you. It's almost completely touch-free. Almost. So what happens is it works very much like regular account linking, and in fact you set it up much the same way. The key difference is that vocally the application will ask the user for permission. It'll say, do you grant permission for whatever it is it's asking for? If the user says yes, then Alexa will send a 6-digit code to the user on their mobile phone. It'll send a message to them with a 6-digit code. The user will then say, Alexa, my code is, and then whatever the code is, and then access is granted. The user doesn't have to walk through the authorization process in the web browser way. They can do it almost entirely with their voice. The only time they really have to touch their phone is so they can take a look and see what that 6-digit code is. However, voice forward account linking is kind of limited. Specifically, it's limited to working with this thing called login with Amazon, or LWA. And unfortunately, LWA is just what its name says. It offers the ability for users to log into an application using their Amazon credentials. And that's about it. It does provide an OAuth token. That's good, but that token is not good for much of anything except going back to Amazon to get details about the user. And in fact, there are other ways you can do that with an Alexa skill anyway. It doesn't offer custom scopes, and therefore, because it doesn't offer custom scopes and because there is no way for the resource server to verify the validity of whatever the token is, it really can't use it to open up an API. The best you could do is provide an API, a resource server that just checks to see if the token's there, and if it is, it lets them in, but there's no way to verify the validity of it or what permissions have been given to it. So honestly, voice forward account linking is very, very limiting, and while it's really awesome right now in what it does, until they fix the problem where it's limited to login with Alexa or login with Amazon, I don't recommend using it. One more thing about voice forward account linking: there is another feature that Alexa offers called voice forward consent. There are a lot of different things that Alexa can do for a user that require permission. And voice forward consent is one of those things that can offer that. Voice forward consent and voice forward account linking, they work very similar. They're in much the same way. They ask the user if it's okay, they send a 6-digit code, the user says yes, and then suddenly they have permission. The thing is, it doesn't require login with Alexa or any authorization server for that matter for most of these consent things. And so because of that, voice forward consent is actually very useful. I've used it recently on a skill that I've created that asks the user for permission to know their location. So if they're actually on their phone talking to Alexa and they're out in the world, it can ask for their geolocation. And of course, the user has to grant permission to do that, but the alternative to voice forward consent is they have to do it through the app. They have to click a few buttons and go through this flow that grants permission, where with voice forward consent, they just simply say yes, and then they tell them what the code is, and suddenly their permission, their consent has been granted. So I like voice forward consent. I'm told voice forward account linking there's a private beta right now that's enabling it for a more general purpose with any authorization server. I am not part of that private beta, so I honestly don't know the details of it, but in its current form, it's very limited. So recap. Alexa offers a hand-free voice user interface. That voice user interface can integrate with any backend, including Spring, via HTTP, RSocket, messaging, or pretty much anything that you can find a communication capability within Node or Python and a backend Spring application. Account linking enables secure access to that OAuth server, and voice forward account linking, it looks promising, but it currently is limited. It's promising in that it makes the flow a little bit easier for the user, but it's limited currently in what you can do with it. So with that said, thank you so much again for joining my talk, for watching. Follow me on Twitter, follow me on Mastodon, email me if you have any further questions, and check out my books. I'm obviously the author of Spring in Action, now in its 6th edition, but I've also authored a book on building talking apps for Alexa, and you should check that out. And over here to the right, I have QR codes that'll take you to where you can see videos that I've been creating on different topics. The one on the left is for Spring, the one on the right is for developing voice applications. And again, with that said, thank you very much.